Hey guys, welcome to week 4 Friday with Dr. Callahan. This is for probability semester 1. Take a look at the 3 questions you have for your warm-up log, pause the video and answer them. All right, let's go ahead and take a look at question number 3. So here I'm asking you guys to graph this. This is in standard form, which is going to be ax plus by equals c, where a, b, c's are numbers. So in order to graph a line, you will require 2 points. And so the best way to do this is by finding the x-intercept and the y-intercept of the standard form. So to find the x-intercept, you would assume that y is equal to 0, and you want to figure out what x is. So the easiest way you can do is just take your little fingers and cover the y because it's going to be a 0. Essentially, it's not going to be there. And then when you look at this part here, you're going to divide it by -2 to solve for x. -16 divided by -2 is going to give you a positive 8. So your first point is going to be 8, 0. So I'm going to graph this 1, 2, 3, 4, 5, 6, 7, 8 right there. When you look for the y-intercept, you are going to assume that x is going to be 0. So I'm just going to go ahead and cross out the x. Here I have -4y equals -16, so I'm going to divide it by -4 on both sides, and the y is equal to a positive 4. So I have 0, 4. 1, 2, 3, 4. There's my second point. Now that I have these 2 points, I can go ahead and just connect the dot, and that is my line. Okay, so your homework from yesterday on the Google Doc for your textbook is for 2 to 24 evens, number 34, 36, 42 to 46 evens, total of 17 questions. These are your answers when it comes to the basic counting principles, permutation combinations that we talked about last class. You need to make sure you show your work and have this on the homework template on the back 5 to 6 pages of your white guided note packet. Make sure it's organized there, and because you will be turning in your packet into me once we're done with all of the sections of Unit 2. And then I will be able to see your homework assignments, which is stable to the back of this. All right, let's take a look at our objective today. Today we're going to go over example, objective 3. I'm going to go over 2 examples on the video guided notes. A third example, you're going to be doing this on your desk. And then we're going to do some practice problems on the right side of the paper that I passed out to you guys. If you're at home doing this, you'll be able to see the guided notes. So you can go ahead and just write it on a separate piece of paper. That's totally fine. So this is your guided notes. You do not have this if you're at home, but if you're going to be with me in person, you would definitely have this. So let's go ahead and take a look at this problem. These are the 2 examples we're going to be going over in class, and we'll start there. Okay, so let's go ahead and go over the differences of permutation and combination. We went over this last time, but I just want to kind of go over this one more time. With permutation, order absolutely matters. So for example, November 2020, we're going to have a presidential nomination. So there's a difference between being the president, the vice president, and the treasurer. Or for example, administration at a school. There's a difference between principal, assistant principal, dean, and teacher. Or if you're going to go to the county fair, there's a difference between the first place winner, second place, and third place winner. So order with permutations matter. And with permutation, this is your formula with a P. Combination, the order does not matter. So if they're going to select 5 students from the freshman class to go to Paris, the 5 students selected, I don't really care if I'm first of 5, second of 5, third of 5. I'm just very happy to go to Paris. So in that situation, the order does not matter. Or for example, the top 5 performing students on exam, yes, there's going to be like probably the highest, the second highest, but if it's just going to be top 5 students, order does not matter. I made it to the top 5, I am good. All right, so let's take a look at the first problem. It says in a group of 10 people, 3 $5 prizes will be given. How many different ways can the prizes be distributed? Okay, so in this case, because it's going to be 3 people and they're all going to get $5, the order does not matter. So if the order doesn't matter, it is definitely going to be a combination. And if you look at the formula for the combination, it is going to be C in R equals n factorial over R factorial, parentheses n minus R factorial. So you know that your n is going to be your 10, your R is going to be your 3. So then let's go ahead and plug this into the formula. So I have C 10 comma 3 equals n factorial, which is 10 factorial, over R, which is 3 factorial, over 10 minus R, which is give me 7 factorial. So let's go ahead and extend this. With the 10 on top, you have 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. On the bottom, you have 3 times 2 times 1. And then also with the 7 factorial, 7, 6, 5, 4, 3, 2, 1. Well, we want to go ahead and eliminate some of the questions or some of the numbers we can. I can see that with my 7 factorial, it matches with the bottom denominator. So I'm going to go ahead and just cancel that out. And I should also explain this a little bit better. The reason why n is 10 is because there are 10 people. N is always going to be the bigger number. R is always going to be the smaller number. So if you're reading a word problem, you're not quite sure which one's which, N is always the bigger number. Because there are going to be 3 prizes of $5 and 3 people will get the $5 prizes, your R is going to be 3. And oftentimes when I'm looking at an example like this, I just highlight the 2 numbers that's given to me and automatically assign the bigger number is going to be C, or excuse me, N, and the smaller number is always going to be C. So let's go back to this. So then as I'm looking at this part continuously, I can see that 2 and 10 divided by 2 is going to give me a 5. And then 9 divided by 3 is going to give me a 3. So then this is it. I'm left with 5 times 3 times 8, which is 15 times 8. And that's going to give me 120. So how many ways can the prizes be distributed? 120 different ways. All right, question number 2. It says a local school board with 8 people need to form a committee with 3 people. So my 2 numbers, 8 and 3. How many ways can this committee be formed? So out of the 8 people, I just need 3 people to form a committee. Order absolutely does not matter. It's not like saying out of the 3 people, one person's gonna be the president, one's gonna be the vice president, one's gonna be the treasurer. So order does not matter. So in which case, you know you're dealing with combination, okay? And these are the 2 numbers, and you know that the bigger number is always gonna be N, smaller number is going to be R. So let's go ahead and write down the formula. So C, N comma R is going to equal to N factorial over R factorial, N minus R factorial. And so given that your C with your N is going to be 8, R is going to be 3, when I plug this into my formula, I should have A factorial over 3 factorial, and then here you're going to have 8 minus 3, which is 5 factorial. So it's just going to save me a little step. So let's go ahead and extend this. On top, you are going to have 8 times 7 times 6 times, I'm just going to put 5 factorial because it's 5, 4, 3, 2, 1. And the reason I'm doing this is because I have the 5 factorial right here. And rather than writing 5, 4, 3, 2, 1, top and bottom, it just saves me sometimes. Because I know immediately I'm going to be canceling this, so it's going to be gone. Now I have 8, 7, 6 on top, 3, 2, 1 of multiples. And so 3 times 2 is a 6. And guess what? That cancels. So then I'm left with 8 times 7, which is 56. And that is my answer. So there are 56 different ways that this committee can be formed with 3 people when there are 8 people that they can select from. If you need to watch a video explaining these 2 examples again, I have a YouTube video that's about 9 minutes. A different person will explain it to you. Maybe they'll do a better job. If you haven't done Objective 3 yet, make sure you finish A and B. It's on page 19. Your exit ticket is right here. You can go ahead and copy this part down somewhere in your guided notes in the white packet. All right, so then the next thing I want you guys to do is go back to the original handout, which you don't have, but I do have it here. Okay, so we're done with these 2 questions that we went over in class. I want you to do number 3 on your own, and it says, how did Dr. Callahan solve the problem below on your desk or on a piece of paper? Please explain the steps, label step 1, step 2, step 2, step 3, etc. And then when you're done with that, go ahead and work on the fundamental counting principle permutation introduction with these 8 questions. Have a wonderful day, you guys. Take care.